In this video, we will generate the Taylor-Maclaurin series sum of the arc sine using the factorial and double factorial. First, to begin with the arc sine. Data set. So array formula, a sine of the x values from 0, negative 0.8 to positive 0.8. And we'll chart this. Insert chart, and we'll use scatter chart. And check use row 1 as label. The series trend line polynomial to the 8th degree. And in the label, use the equation. The legend position at the bottom. The horizontal axis number format will be none. The vertical axis show the axis line, that's the axis line, and the number format none. And here we have the trend line and the trend line polynomial of the arc sine function. Next, we generate the Taylor-Maclaurin series sum expansion, which is the summation of a times x to the power 2n plus 1, where a, the coefficient, comes in the full two forms. A1, which is the factorial, that is factorial 2n, all over 4 to the power n times factorial n squared times the quantity 2n plus 1. And the double factorial, this will be double factorial 2n minus 1 all over double factorial 2n times the quantity 2n plus 1. And the value of n, 0 to infinity. In this case, 16 is good enough. So we continue with the double factorial coefficient. So array formula, that is fact double. That's double factorial. 2 times n minus 1. That's the numerator. Now the denominator. There are two parts. First part is factorial double. So since we'll be using n too often, so we'll just copy that. So the second part is factorial double factorial. 2 times n times the second part, the quantity 2n plus 1. 2 times n plus 1. So we have completed the two parts of the denominator. And we'll correct this. So if n equals 0, then it's 1. So if n equals 0, then 1. Otherwise, calculate. Then enter. Now it's corrected. We continue with the factorial. So a1. So this is equal to array formula, the numerator, which is factorial, 2 times n. That's the numerator. That's the numerator. So divided by, now we go to the denominator, which has two parts or three parts. So the first part is 4 to the power n. So 4 raised to the power n. The second part is factorial n squared. So factorial n raised to the power 2. That's the second part. The third part the quantity 2n plus 1. So 2 times, so 2 times n plus 1. So the first part of the denominator, the second part, which is factorial n squared, and the third part is the quantity 2n plus 1. 2 times n plus 1. Now we enter. These values is equal to these values. Now we can continue with the Taylor-Maclaurin series sum. So RA formula, series sum of the x values raised to the power 2n plus 1. 2n plus 1 starts from, that's 2 times 0 plus 1. That's 1. So 2n plus 1 starts with 1. The increment. Next will be 2 times 1 plus 1, 3. 2 times 2 plus 1, 5. 2 times 4, 2 times 3 plus 1, 6, 7. 2 times 4 plus 1, 9. So 1, 3, 5, 7, 9. The increment is 2. And the coefficient. You can use this. Let's use this. That's the coefficient. These values are equal. Then we generate the Taylor-Maclaurin, the polynomial of the trend line. It's a trend line polynomial to the 8th degree. Use the equation as label. Let's look at the equation. They're actually the same. And their trend lines, they're also on the same trend line. We'll calculate these polynomial regression coefficients using Linus. To do that, we complete the Linus matrix, starting with the power. Transpose 0 to 8. Then the elements of the matrix. So this will be RA formula of the x values raised to the power 0 to 8. Now we can calculate Linus. So starting with the arcsine function, which is R Linus data y and data x. Enter. Those are the coefficients. Linus, this time the expansion, data y and data x. And enter. They are the same. So the polynomial regression coefficients are the same. So starting with the coefficient of x to the 0, 0. Coefficient of x, 1. Coefficient of x squared, 0. Coefficient of x cubed, 0.172. Coefficient of x to the 4th, 0. Coefficient of x to the 5th, 0.0361. Coefficient of x to the 6th, 0. Coefficient of x to the 7th, 0.132. And coefficient of x to the 8th, 0. Suppose I use the factorial. So I'll change this to d. D, instead of E, it's D. D3 to D19. Then enter. I still get the same data sets. The trend lines are on the same trend line. The polynomials are the same. The polynomial regression coefficients are the same. I put back to the double factorial. So I change this to E. E3 to E19. And enter. Again, the data sets are the same. The trend lines are the same. The polynomials are the same. The polynomial regression coefficients are the same. So that's for the factorial. The double factorial, that's E3 to E19. So if we go back to the factorial, D and enter. we still get the same values. This completes the use of factorial and double factorial to generate the Taylor-Maclaurin series sum of arcsine, and using the array formula and the in Google Sheets or Excel.